Welcome to the Universiti Utara, Malaysia School of Computing. To write secure code and administer robust networks, we have to start by mapping exactly how adversaries think. Let's start with a baseline. In a healthy network flow, a user connects through the internet to a web or database server. But this pipeline can be intercepted at three distinct layers: the user endpoint, during network transit, or at the application database. Effective network defense requires categorizing threats by exactly where they attack this pipeline, starting with the outer edge. This diagram outlines the mechanics of 8 common cyber attacks. Looking at the first panel, we focus on the endpoint, the human layer, which is often the weakest link in any system architecture. Here, phishing acts as the primary tool for social engineering. The attack lifecycle is direct. An attacker sends a deceptive message, the target opens a malicious link, and the hacker directly harvests the submitted credentials. Moving down to the second panel, ransomware acts as a secondary endpoint attack. Instead of stealing passwords, it weaponizes encryption to hold local user files hostage. While this specific graphic illustrates an infected pen drive as the physical delivery vector, phishing links are highly common deployment methods for this exact same encryption malware. In both cases, attackers successfully bypass complex technical firewalls simply by exploiting basic human trust or leveraging direct physical access. Next, we shift to Layer 3 and 4 vulnerabilities, the network and transit paths. Panel 3 shows a denial-of-service attack. Notice the specific architecture here. This illustrates a DNS amplification reflection mechanic. Bots send small spoofed requests to an open DNS server. That server then unleashes massive, overwhelming responses directly onto the target server, overloading the system. Moving to Panel 4, man-in-the-middle attacks show how transit traffic is silently intercepted. The original connection is severed, and all data is routed entirely through an unseen attacker. Panel 8 details DNS spoofing, which operates differently. This attack involves poisoning the internet's routing ledger itself. This is distinctly different from phishing. Here, the user types the exact correct URL into their browser, but because the attacker injected a fake DNS entry, the poisoned infrastructure resolves that request to a malicious IP address. These transit attacks prove that secure channels and verified routing are mandatory. Both the user and the server can act perfectly, yet still be compromised somewhere in the middle. Finally, we shift to Layer 7, the application layer, where the system's own code is weaponized. Panel 5 introduces SQL injection. When developers fail to properly sanitize inputs, attackers can append malicious logic directly to back-end database queries, allowing them to extract unauthorized data. Moving down to Panel 6, cross-site scripting, let's pause the video for a moment. If an SQL injection tricks the server, who is the actual victim of an XSS attack when the script executes? Take a second to write down your answer. In cross-site scripting, the database merely acts as a storage vessel for the malicious script. The true victims are the other users' browsers, which retrieve and execute that payload when they load the compromised page. The final piece of this layer is the zero-day exploit. These are unknown vulnerabilities weaponized before developers even realize a security flaw exists, leaving 0 days to mitigate the threat. Application layer attacks occur because of inherent flaws in developers' logic, turning the application's intended features into weapons against the system itself. Looking at the complete map of these 8 cyber attacks, we can organize them structurally into the 3 distinct zones we mapped out: endpoints in blue, network transit in yellow, and application code in red. Defending this architecture requires a layered defense-in-depth strategy: continuous user training for the endpoint, strict encryption for transit, and rigorous input validation for code. Apply this theoretical matrix to your upcoming practical lab assignments. Your mandate at the UMM School of Computing is to build secure architectures from the ground up.